Ever wondered how websites process your data? Today we delve into the world of server-side programming. It's a critical aspect of web development, focusing on the software and systems that run on servers. This is a contrast to client-side code which runs on your web browser. Server-side programming is about creating the logic and functions that process your data, handle database operations, manage user authentication, and ensure you get the right data when you need it. In this video, we'll be covering key aspects such as the languages and technologies used, the frameworks and tools that speed up development, how we interact with databases, the importance of APIs and middleware, and of course, the crucial security considerations. So buckle up as we embark on an exciting journey into the world of server-side programming. The first step into server-side programming involves choosing the right language. Now let's delve into some popular server-side programming languages and their key features. First up, we have Python. Known for its readability and vast libraries, Python is a firm favorite among web developers. It's especially popular when paired with frameworks like Django and Flask, which make it even more powerful and versatile. Then there's JavaScript. With the advent of Node.js, JavaScript isn't just for the front end anymore. Now, developers can use the same language on both the front and back end, streamlining the development process and allowing for greater consistency. Next, we have the stalwart of the programming world, Java. Known for its robustness and cross-platform capabilities, Java is a common choice for large-scale web applications. It's a heavyweight contender that has stood the test of time. PHP also deserves a mention. Originally designed specifically for web development, PHP is easy to start with and is deeply integrated with the web. It's a language that's been around the block and still holds its own. Lastly, there's Ruby. Known for its elegant syntax, Ruby is often used in conjunction with Rails, a powerful framework that emphasizes convention over configuration. It's a language that values simplicity and readability, without sacrificing functionality. These languages, however, are just the tip of the iceberg. There are many others out there, each with their own unique strengths and use cases. Some developers might prefer C# for its integration with the .NET framework, while others might lean towards Go for its performance and simplicity. The choice of language often depends on a variety of factors, such as the specific requirements of the project, the existing infrastructure, and of course, the personal preference of the developer. It's important to research and experiment with different languages to find the one that best suits your needs. While these are some of the popular languages, the choice ultimately depends on the project requirements and your personal preference. So explore, experiment, and embrace the language that resonates with you the most. Languages alone cannot do the job. They need the support of robust frameworks and tools. Now, let's delve into the realm of frameworks and tools. These unsung heroes provide a structured skeleton to build our server-side applications upon. They can significantly speed up development by offering built-in components for common tasks, such as routing, session management, and security. Starting off, we have Express. This JavaScript-based framework prides itself on its minimalist yet flexible nature. It's the go-to choice for many when developing web and mobile applications, due to its simplicity and adaptability. Next on our list is Django, a Python-based framework that follows the batteries included philosophy. This means it provides almost everything a developer could need to build a robust application. It's like a Swiss Army knife for server-side programming, making it a popular choice for many developers. Moving on, we have Spring Boot. This Java-based framework is an excellent choice for building high-performing, enterprise-level applications. What sets Spring Boot apart is its simplicity in configuration and deployment of Java applications, making it a beloved tool in the Java community. Last but not least, we have Laravel. This PHP-based framework provides a clean, classy, and dare I say, elegant environment for web development. Laravel offers powerful features like object relational mapping, routing, and authentication, making it a strong contender in the PHP world. These frameworks, each with their unique strengths, are quintessential for server-side programming. They help us build applications that not only function well, but also maintain a high standard of code quality and structure. But frameworks aren't the only tools we lean on. We often use additional tools to manage databases, test our code, and automate deployment. These tools, along with the frameworks, form the backbone of our server-side programming ecosystem. In conclusion, frameworks and tools are the unsung heroes of server-side programming. They not only make the development process easier, but also more efficient and organized. So the next time you're coding, remember to appreciate these powerful allies. Data is the lifeblood of any application. Let's understand how server-side programming interacts with databases. When it comes to server-side programming, one of the key tasks is to interact with databases. This interaction allows us to store, retrieve, modify, and delete data. The type of database we choose depends on our specific needs. SQL databases like MySQL, PostgreSQL, and SQLite are traditionally used for their structured format and powerful query language. They are excellent for applications that require complex transactions and have well-defined schemas that won't change much over time. On the other hand, we have NoSQL databases like MongoDB and Cassandra. These databases are known for their scalability and flexibility when dealing with unstructured data. They are particularly popular for applications that need to handle large amounts of data and need quick read-write operations. But how do we interact with these databases? Well, this is where ORM, or Object Relational Mapping, comes into play. ORM libraries provide a way to interact with your database, like you would with SQL. In other words, they convert data between incompatible type systems in databases and programming languages. For instance, we have Hibernate for Java, Sequelize for JavaScript, and Active Record for Ruby. These libraries abstract the underlying SQL commands, providing a simpler and more intuitive way to interact with databases. They also help in managing database connections, transactions, and often offer features like lazy loading, caching, and more. But remember, while ORMs can make life easier, they can also introduce performance bottlenecks if not used properly. It's important to understand how they work under the hood, especially when dealing with large datasets or complex queries. In conclusion, the interaction with databases is a crucial part of server-side programming. It's about understanding what kind of data storage you need, choosing the right database for your application, and knowing how to interact with it effectively. A good grasp of database interaction is invaluable in server-side programming as it allows you to effectively manage and utilize data. Modern web applications communicate via APIs. But what role does middleware play? To understand this, let's first look at APIs, or Application Programming Interfaces, particularly RESTful APIs. These are sets of rules that allow different systems to interact over HTTP. Think of them as the waiters of the digital world. They take your request or command, go to the kitchen, in this case the server, to fetch or modify data, and then bring the response back to you. RESTful APIs are particularly popular because they use standard HTTP methods, making them easy to understand and use. Now, onto middleware. Middleware is like the traffic control center of our server-side programming. It's software that lies between the application layer and the network layer. Its job, to handle a multitude of tasks like authentication, logging, and request handling. Middleware acts as a facilitator, making sure everything moves smoothly from one point to another, just like traffic lights guide cars and pedestrians. So, when a request comes in, middleware can check if you're logged in, if you have the right permissions, and it can even modify the request or the response. It's a powerful tool that can streamline processes, reduce code duplication, and make our applications more modular and easier to maintain. In essence, APIs and middleware are like the conductors of our digital orchestra, ensuring all parts communicate and work together harmoniously. APIs and middleware are key to ensuring smooth communication and operation in server-side programming. Security isn't an option, it's a necessity. Let's discuss some security considerations in server-side programming. In the vast digital landscape, the importance of security cannot be overstated. When developing server-side applications, building a secure environment should be a top priority. One common vulnerability is SQL injection, where malicious code is inserted into strings that are later passed to an instance of SQL Server for parsing and execution. To guard against this, always use parameterized queries or prepared statements. Never build SQL queries using string concatenation of untrusted input. Cross-site scripting, or XSS, is another frequent security concern. It allows an attacker to inject malicious scripts into web pages viewed by other users. To protect against XSS attacks, you should escape user input and adopt a content security policy. Then there's cross-site request forgery, also known as CSRF. This type of attack forces an end user to execute unwanted actions on a web application in which they're authenticated. Mitigation strategies include using anti-CSRF tokens and implementing same-site cookies. Beyond these, using secure protocols like HTTPS, validating and sanitizing input, managing user sessions securely, and keeping dependencies updated are all crucial practices in maintaining a secure server-side environment. Remember, security isn't just about building walls to keep the attackers out. It's also about knowing what to do when they get in. Regular audits, logging, and monitoring can help detect and respond to breaches swiftly and effectively. Remember, security should never be an afterthought in server-side programming. It should be integrated into every step of the development process. Let's do a quick recap of what we've learned about server-side programming. We've explored the diverse landscape of languages and technologies, from the readability of Python to the versatility of JavaScript, the robustness of Java, the simplicity of PHP, and the elegance of Ruby. We've delved into the world of frameworks and tools, understanding how they can streamline our development process. We've discussed database interaction and the importance of ORMs in managing complex data structures. We've also looked at APIs and middleware, seeing how they enable communication between different systems. Finally, we've touched on security considerations, recognizing the critical role they play in protecting our applications and data. This has been a broad introduction, but remember, each of these areas warrants deeper exploration. With these fundamentals, you're now better equipped to explore the vast world of server-side programming. Until next time, keep coding.